All right, now we're going to have a look at more volumes of revolution. We're going to take this area in here between two curves and then rotate that around. So essentially what that's going to do is rotate this whole bit around under the, and then minus off this triangle that's been rotated around from the straight line here. Okay, so now what's that going to do? What's that formula going to look like? So that volume is going to be pi between some limits a and b of the top curve squared, so we'll call that y1 squared, minus y2 all squared dx. So that's the top curve squared, so this one, y equals 4 minus x squared. We're going to rotate that around between between 0 and whatever this value is. Call this b and this a. And y, and then we're going to minus off this area that's been rotated around here. So this minus this function, 3x, rotate that around. So how do we find this a and b? Well, we've got to find where they intersect here. So I'm going to go 3x is going to equal 4 minus x squared. So then we get x squared plus 3x minus 4 equals 0. And if I factor this, I should get minus 4x, no, plus 4 minus 1, that's better, equals 0. Therefore, x equals 1. I'm ignoring this because that's a negative solution. That's where it crosses down here. I want the positive one. So x equals 1. So the volume I want is pi between 0 and 1, okay, of our first function squared, 4 minus x squared squared minus 3x all squared dx. Now that should give us a volume. So let's expand the brackets out. What do I get? 16 minus 8x squared plus x to the 4 minus 9x squared dx. Okay, I can add some like terms there. 16 minus 17x squared plus x squared dx equals pi times, you can take that integral, 16x minus 17 on 3 x cubed. Oh, what have I done there? This should be a 4, x to the 4, plus 1/5 x to the 5. There we go. Oh, we want to evaluate that between 0 and 1. When we put in 0, that's just nothing. So let's just evaluate it at 1. I get, well, I do 16 plus 17 on 3 plus 1/5. Okay, so I need to go pi. Now I need to get all these over a common denominator here. So common denominator 15, so 16 times 15. 16 times 15, what's that? That is 210 plus 30, which is 240 over 15 minus 17 times 5. 17 times 5, that's 170 divided by 2, 85. 15 plus times by 3 on 15. Okay, so what's that equal to? I'll just put it over here. That equals 240 minus 82. 240 minus 80, 160, 158 pi on 15 cubic units. Okay, and we're done.